Hi guys, welcome to another Learning Electronics Repair video. This is the GTX1070 that we were looking at a week or so ago, and basically we found a fault on this. This is the VRM that effectively generates the VMem or VRAM, the supply to the memory, and it wasn't working enough to, much messing around. So after much diagnosis, and I'm sure you'd like to watch the first two parts of this repair, so I can link them here. After much diagnosis, the fault was traced to a missing timing resistor that sets the frequency of the oscillator, and the missing resistor is just here. And I didn't know what the value of the resistor should be. I have a similar gigabyte schematic which is not the same as this, and thought it was possibly 383 kilo ohms. The datasheet for the VRM controller suggested it could be 500 kilo ohms, so I left it at that because it's a critical component. And then I published the video, and one of the subscribers came along and actually said he had one of these or several of these cards, and he measured this for me, and he says this is definitely 383 kilo ohms. So now is the time to replace this resistor, so we'll get a resistor replaced here, and then let's power this board up and let's see if we now have voltage supply to the RAM, and if we do, maybe even it'll be working. Alright, I'll get the microscope and let's get the soldering iron, and then we'll just do a little bit of soldering. Now hereby lies a problem. I don't have any 383k resistors. I have a whole book full of service mount resistors, yeah, all sorts of values, loads and loads and loads of them, but I don't have any of that value. I had a look on AliExpress, and I can see, if I'll just show you, if we can just go over to the screen, that you can get these. They're 1% resistors. They come in a whole pack of them. Actually, I'm not sure how many you get in a pack. 5,000 pieces. I need to find, if I can even find kind of like a small quantity of them, but basically I'm gonna have to buy a resistor to this unless I find a donor board with one on. But I'd like to prove to see whether or not there's actually a problem with something else. In other words, would this actually fix the problem? So what I'm going to do is I'm going to take some normal through-hole resistors. I can just show you basically what I'm going to do is I'm going to take, I have some resistors of various values, through-hole resistors. I'm going to try and make up a resistance of the right value, and then once I've done that, I'm going to kind of strap it across the pads and see if this thing actually powers up. If it powers up, I can probably test it even with this attached to it, and if it's working I can then get the part. So this is a 180k resistor, and that is 180k. Okay, so we've got a 180 there. We need to make up 383. Here's another 180, that's really 179.2. Okay, so that's effectively 360, just a bit less. This is a 22k, it's slightly low, so that will give us 382. Here's a 1k, which will give us 383. But what I'm going to do is I'm going to actually, I'll solder them in a minute, but let's actually strap a few of these together and measure the actual resistance. I probably ought to put a bit of solder on just to actually make sure I've got a good connection on them. So let's just do that. So that's those three together. Just solder those one moment, because I want to try and make this accurate. Yeah. If I put these three together, I'll know then probably what value to make for the last resistor. Okay, one moment. I just have to warm the soldering iron up. It's gone to sleep. Okay, so I've soldered those all together, those three. So we can have a look and see how close this actually is now to have a 383. So we'll just measure from here to here. And what do we have? We have 380, so I need 3 more K. So let's put a 3.3, and that'd be like 383.3, and that's like within the 1% tolerance. Okay, so I'll do that. Oh, actually, I can do slightly better than that. So I happen to have some 3K resistors. I didn't think I would have them. 3K. Let's see what we have. 2.948. That's close enough. Yeah, so we can attach this onto the little chain of resistors. Okay, like so. Solder that on. Okay. Now let's see if we actually have a 383k resistor. That's a bit Heath Robinson, but you know, it'll do a job, I think, to prove this. So we go from one end to the other end now, and we should have 383. Huh, 385. Wasn't that just typical, as he said? I won't put my fingers across because I'll just read it lower. $385. I'll just check if that's actually within tolerance of 1%. One moment. Well, I've actually taken a 1K resistor now instead of the 3K. I'm not quite sure why it changed the value, but I can see that this actually reads, if we just get across it, 383k. Okay, so I actually have a 383k resistor here. What I'm now going to do with this is effectively solder it to the board across the pads where this resistor goes. It's quite easy actually, because there's like a wire that was near to it at one side, and the other side is 12 volts, so it's easy to get to. So let's zoom down here with the microscope and let's have a look. Well, quite conveniently, they've made this a bit easy for us. So what we can do is we have this little wire and some pads here. If we just get to them, I'm going to look down the microscope. It's a lot easier for me to do it this way. Okay, so this is the wire. A little bit of flux will help with that. A moment. Okay. So again. I've got one of the pads, that's not a problem. So we can tag one end of our resistor onto here. Just get to where it is. Okay. No, it's not getting a good grip. I'm going to have to get some solder onto that wire, guys, to get the thing to actually just solder properly. I'll just get onto this. Yeah, that's a bit better. Let's have another go. Try to get our resistor onto here. This is why I use this chunky soldering iron bit, because it gets much more heated than a fine one. You'd struggle to do this with a fine one. So that's on there. And then the other end, this big pad here, this is 12 volts. So I'm sure I can find probably at one end of one of these capacitors that's on the same as that. Let's get the meter. You'll be able to see it actually. So there we go. So this track here, this is 12 volts, and I'm guessing it goes here somewhere. Yeah, it goes to there. Does it? No, maybe it doesn't go to there. Just to find somewhere this goes. If not, I'll just scrape a bit of it off and I'll just solder to it. Just wants to get onto it again. Maybe that's where the resistor was broke off. That's the trace. It does in fact go to this end of this capacitor. That's interesting. It doesn't look like it actually goes to it, but it does. Hang on, let me look at the resistance. Maybe it's not reading 0. One moment. That's the problem when you're wearing glasses and using a microscope. Yeah, it does. It goes to there. Okay, so we can tag that onto there, and then we've got the resistor, and then we can measure. Anyway, we can measure from this other end of the resistor to ground. It should be 383k. Sorry, not to ground, to 12 volts. So it should be 383. So let's get a bit of soldering on here. this little pad. Doesn't want to take any solder even with the flux on it. A little bit on the wire. So it has to go onto here. Now it's taken a bit. Make sure I've got a good connection. Okay, so there's a little codge, but at least we've got our resistor soldered across. Let's test it now. So we should have from this end of the resistor, this is where the wire was, to 12 volts on the PCIe should be 383. Let's have a look. 12 volts comes in here. 383. Yeah, it's there. Okay, so it's now fastened on. So let's see if we can actually test this, power it up, and see if we now have any supply to our RAM. Okay, I had a bit of a thought about it. What I was going to tag the end of the resistor over to here, which I thought was 12 volts, but this looks like this pad doesn't actually attach directly. I think it comes to this little resistor up here, which could be the 2 ohm resistor that we saw on the gigabyte schematic. But having said that, it reads 0. But anyway, I decided to tag the other end of the wire directly down to 12 volts. So let's just clean this up a little bit and we can have a quick look at what we have. That's it, let's just clean that off. Get a bit of kitchen roll and then let's see what we have. Okay, so I've cleaned it all up, and as we can see from here we have 383k to here, yeah, and this point here is connecting to the 12 volts coming on the PCIe. If I can just get a connection onto it, there, that's onto the first 3 fingers. So we have it, we have our resistor in place. So yeah, now let's just let's power this up and let's see if we actually have any supply to the memory now, and if it does anything else, maybe it works. I've balanced the cord upon a couple of bits of cardboard basically, so that it doesn't squash the resistor against the board. This is where VRAM is. We can make sure we've just got a connection. Yeah, we have a reading the resistance of the RAM. So let's now power this up and see if it finally actually have any VRAM. And yes, we do have VRAM. That's a very good sign. Do we have anything else? No, you only have a bleep. Oh, we have a picture coming out of it. Okay guys, we've now got a picture coming out of our card. So let's put the heatsink on. I should be able to do that. Just put this side heatsink on with those resistors in place, get this in the PC, and let's see if I can actually load the drivers and boot into Windows. Well guys, as seems to be the case with these graphics cards, I loaded the drivers and it crashes, you know, partway through loading the drivers. It just crashes. I've tried a couple of times. I even got my other old test rig out and put it in here and put a fresh installation of Windows on, and I tried loading the drivers and it just gives a black screen. So there we go. So normally the reasons for this, the most likely, would be faulty RAM. It could be one of the VRMs, voltage not stable under load, or it could possibly be the GPU itself. I mean, there may be like broken or missing capacitors causing instability on some voltage rails. So anyway, sitting in here, you can see it. In fact, you can see my little cobbled together. Can you see it down there? Let's get a good angle on the thing. Upside down, yeah. I'm sure you can actually see my resistors. Yeah, you can see them sticking up there. That's my little cobbled together 383k resistor on it. So let's run a memory test on this, and let's have a look first to see if we got any problem with the RAMs. Okay, so to run a memory test, I'm going to use the King's Overkill files. I put these on a previous video. I'll link it from this video, and also the files to download. You can either get them from the original link, because I didn't create this software, or I also have links on the video where the files are actually on my Google Drive. You can download from there. So option 2 was for 7 series GTX, so we're down to 2 and we'll press OK. Okay, now this will actually run a test. Here we go. Takes a few seconds. I'm not sure how many megabytes this is testing, or which, you know, whether there's different settings for the test program. But we'll let it run anyway, and we'll see what happens when we get to the end of it. I think it'll take maybe another 20 seconds or something like that. Okay, and that's giving us a fail, but it's not really telling me. I mean, I can see some stuff up here, but I can't actually see anything to say where the fail is. So let's run the test manually. So we type ls, this will actually list the contents of the folder I'm in, and you can see there's various ones for various graphics cards. There's a folder called GTX1070. So we'll go into that one, CD GTX1070. Okay, ls. We're in that folder now. There's all the stuff in there. The test program is called MATS, M-A-T-S. If you put the argument -H, that will give you the help. So it shows you the various options, the arguments. The first one is the one I'm interested in, which is -E, and that forces an endpoint of test to so many megabytes. So you put -E and a number, that's how many megabytes it's going to test. So let's have a look. So we've got MATS -E. Let's go 20 megabytes, okay. And then we need to send the report to somewhere that we know where it is. So this little symbol, it's like a little line with 2 dashes here, a long stretched colon if you like. It's called a pipe. And if you put that in, you can then send the report wherever you want. So I'm going to send it to report.txt. And I'm going to, oops, in fact I missed out a P, report.txt. And if I press OK now, this will start the test and test 20 megabytes of the card. So let's actually have a look to see what it does. Well, it gives us some nice rainbow flashing colours, that's what it does to start with, yeah. So yeah, let's see. I'm not sure quite how long 20 megabytes would be, and I'm not totally sure if that's finished. It seems to have like stopped doing stuff and maybe just left a lot of like junk on the screen maybe. So I'm going to try and quit that, and let's have a look if I get out of it. If not, I'll restart it and then see if I've got a report.txt with 20 megabytes. So let's have a look anyway. Let's see what we actually got, if we got a completed report. So I'll just restart it. Only take a moment. There we go. I'll just pause it while it restarts. You've seen it go around it once before, so no point to see it all again, I'm guessing. Okay, that's its test at start. So I'm going to go into the CD, into the GTX1080 folder again. Okay, and let's have a look see if our report is actually here. LES is a Linux command that will basically display text files a page at a time, which is what we want. So LES report.txt, and there's our report. And is it the one we wanted? Yes, 20 megabytes. And that's telling me that there's no errors in the memory on this card. And I'll be totally honest, guys, I'm not 100% sure why I see the fail when this gives me in the report that there isn't any errors, yeah. You see all the various bits there and the various banks, A, B, C, D, E, F, and there's nothing. So to me that's a bit inconclusive as to what the problem is with this card. So I'm going to try see if I can prove if it's one of the other things, and I'm sure I'm going to publish this as somebody will tell me if I'm making some mistake running this memory test on this card. Okay, so how am I going to figure out if one of the VRMs is unstable? under load when we load the drivers. And I think the easiest way to do that is to connect. I have 2 or 3 multimeters, and if I solder some wires, one to VCore, one to VRAM, and one onto PEX, because those are all the supplies that actually go to the GPU, I should be able to then monitor all the voltages and try to load the drivers and see what happens when I do so, or if there's something notably not stable. Okay, well, it's going to be interesting, so let's get that sorted. Okay, so I have this all kind of like lashed together. Yeah, you can see on the bench I have the 2 meters and some crocodile clip leads. I've actually soldered the leads to the back of the graphics card. I'll just try and get this into a position where you can actually see it. So yeah, there's a green and an orange wire there tagged onto the graphics card, one on VRAM and one on VCore. There's my little box still down there with the resistors. Yeah. my little Heath Robinson repair there, yeah. So it's all ready to go. You can see the screen there. So I'm now going to boot this up. So on here, this is VCore, and on here, this is VRAM. Okay. So just go to the lit up. Yeah, if that helps you to see. Let's just try and get. Okay. Yeah, I'll just try and make that a little bit easier for you to see, and then we'll do it. Oh, there you go. Okay, so that's the 2 meters. So everything's ready to go. So we're going to power this up. So 1.5, this is your VRAM, and this is your VCore 0.893. This is set to boot now. So this is going to boot from the hard drive. It's going to load Windows, and then it's going to load the drivers. And it's just complaining about the CMOS. Let me just fix that. There we go. And at the point the drivers load, it just goes blank. So you'll see what happens. Yeah, here comes your Windows logo. It's going to take a couple of minutes, guys, so you can skip it forwards or that. But I want to show you what actually happens with this. And I have one phone call coming in the meantime. I'm on. Hello? Yes, Richard speaking. I'm really struggling to get skies at the moment, mate. I'll try tomorrow, I'll speak to him, but it's a lot more difficult than it used to be. But I'll do my best for you. I'll let you know on that tomorrow, on that one tomorrow. I picked it up today. Yeah. Right, cheers, mate. See you later. Hey guys, sorry for the interruption there, customer. Okay, so yeah, anyway, while I was away, it's happened. So we can see the VCore's gone up and the screen's gone blank, and it seems to me at this point it just gives up the ghost. So it's not like, I don't think the VCore's unstable. I don't think it's actually, you know, wandering around. I think it's simply a matter that when it loads the drivers, it goes up. If I just try to shut the to restart the machine, see if I get to shut Windows down. There we go, just shut it down, restart it again, and I'm sure this will come back then, yeah, with the lower one. Yeah, this seems to be an interesting phenomenon. I've seen it a couple of times now, but this is the first time I've actually put it on video. Oh no, maybe I did on a GTX 1070 as well. Okay, so I mean, basically I fixed the problem. I fixed the VRM. I've got voltage to RAM now. It seems to be completely stable. And when it goes wrong, obviously the voltage on the VCore goes up. And I'll be quite honest with you guys, I don't really know whether that is a problem with the GPU, whether it's a problem with the VRM. I suspect I'd have to check maybe to see if I can look at the VID, the voltage ID coming from the GPU to the VCore VRM, and see if I can intercept some data. I'm not sure. Or it may just be that it literally crashes when the voltage goes up, or does like it crash under load and then the voltage goes up. Oh, this is it's interesting. But listen, guys, I'm learning as much as you are with this one. This type of problem I've generally found the most difficult to repair so far. So I thought if I upload this video and you know, several heads being better than one, we might get some consensus of opinion of maybe how to proceed further with this and maybe diagnose where the problem is. Is it a problem with the RAM and I'm just not picking it up properly in the way I'm making the test? Is it a problem with V-core increases and then the GPU crashes? Or is it the case that the GPU crashes and then somehow messes up the VID, the voltage ID going to the VRM, and then the voltage goes up? That's an interesting one. Okay, guys, well, let's discuss that in the comments below, and I'm be very, very interested to see what some of you guys think about this video. All right, guys, have a good think about it. Adios, amigos.